Okay, hello everyone. Today I'm going to give a talk about world models, what it is, and one specific paper that covers mechanistic world models. I'm not actually sure where I got this paper initially, Sergey.
That's not the one I gave you.
Yeah, I think maybe Alex posted it into deep learning channel, and I saw something. Oh, yeah. The paper itself is related to world models. So I think I will start with talking about world models in general, what are they and how they're different from regular models. And then talk about, I will talk more about the things that are special to the paper that presented them. Okay, so what is a world model to begin with? So in machine learning and deep learning, we have regular predictor models that are doing something like you give them an image or a text or an audio, and they do some processing and they give you some kind of prediction, like, is this audio recording belongs to one person or not? Is this image contain hedgehogs or not? Is this text a scientific article or not? So this is predictive modeling. And this kind of modeling we saw in the latest decade that these models can do really good predictions, but it is not always easy to explain how these models are making those predictions. And so there is a lot of work that are trying to make explainable machine learning, explainable AI, methods that can give you mechanisms, explanations to how the data is organized, and how we can use machine learning models to explain something about the data. So world models is one of the approaches to this problem. I think the idea is you can make a machine learning model, a deep learning model, into something like a world simulator that encodes the rules of your world inside the weights. And as this simulator trains, it learns something about the world. And once you train it, you kind of have a machine mechanism that you can probe, poke with stick and see if anything changes about the model. And through this, you can learn the world that the model was learned from, something like that. The paper I'm covering is introducing this picture, and it kind of summarizes the conceptual difference between forecasting models and world models. This green box is telling you what model is doing inside this forecasting or whatever prediction pipeline. So in forecasting, the model is only concerned with data and predictions. It takes some data in, it processes it inside, and it makes predictions. And the only point is to make a good prediction. With world models, you are trying to do basically the same to make a good prediction. But the middle step of this process includes generating the world inside the model, generating some kind of latent space, in which is itself predictive for the process you're trying to predict, and it somehow organizes this underlying thing into an interpretable concept. So for example, if you are making a model that will predict the orbits of planets in the solar system, you can train them on the data, and they can learn to do good predictions, but they can learn to do that without learning the Newtonian mechanics. And Newtonian mechanics is a set of rules that gives you like toolbox to give those predictions well. And in a way, it is a world model. And so the world model will try to make predictions by learning the underlying mechanisms. A prediction model is going to learn to make predictions, but not necessarily from the concepts that generated the data in the first place. Yeah.
Do you remember the paper that we talked about? It was like the Platonic representation hypothesis. I'm curious if like these are related to that. Like I'm assuming like this type of thing assumes that everything is generated from some kind of like manifold type thing. Is that like kind of a correct understanding? Are
I
they
think
related?
it's kind of related, but I don't remember exactly what it is about. What's going on?
But it's circular, right? So wouldn't it be creating like wouldn't it be creating something, whether it's true or not? Like as long as it's created, right? I don't think it's about truth, right? Because I guess it's learning. Never mind, there's learning.
Are you talking about these like arrows and cycles here?
Yeah, sorry, I was looking more. I was emphasizing probably a little bit too much on this.
No, but learning is only SGD right now, right? It's offline.
Okay.
Learning is your pass batch through, compute the gradient, apply the gradient. That is your loop, right? So
Got it. Okay.
yeah. So there is no dynamics in the model besides the SGD driven dynamics. Your model is different. Yeah, I think that's not what they meant, right? And then you make a predict like this discovery, I think also, well, both of them, this experiment and explanation are outside of the data and the model. So you apply the model, oh, you see it doesn't work. You go back and mess with your data, run training again, think, oh, okay, I have my model ready. Then do it again. And also you also think, like this happens in our heads and in our world. This happens in a GPU.
Okay.
And only when training. That's my interpretation. So this happens in the GPU and only when training as well, right? So we're kind of removing the explanation from our head. We're saying the model will make up an explanation for itself in like correctly you caught. Like one of the ways is the representation space where those vectors are mapped will become semantic space eventually. That is a static explanation.
So we're assuming there's one manifold like that for the entire world. Whatever our world is,
whatever our world is, maze world, right?
Yeah.
If you are a mouse and you're only tortured with running in mazes and that's all you see, I guess humans are like that.
Truth.
By the way, who presented on this Platonic?
I think this was actually Sergey's presentation.
I don't know. Yeah. Must be mine. Yeah.
Do you remember anything about it? Is it related to world models? I don't remember much.
Well, but it's not related to the world models the way I'm thinking about it. And it's not related to the world models the way we two have discussed those. But this paper is not related to that either.
Yeah.
This is
It would be also nice to discuss, well, the different ideas about world models.
Yes, but that's my presentation on next Friday,
Yeah.
which I haven't started even reading for yet.
By the way, did we talk about something about like preparing questions for your presentation? Like figuring out, using this presentation to figure out what to cover in yours?
Yeah, we could. Yeah, I haven't started, so I'm open to suggestions.
Can you?
Sorry,
you have a question?
Yeah, sorry, one last clarifying question. So the green box is what we're doing. I think that's where I was confused.
No. The green box fits inside of a GPU.
That's the GPU. Okay, so
Yes.
outside is what
The green box sits inside of GPU. Those are your parameters and what happens inside of a GPU.
Okay, got it.
Like just for simplicity, I mean,
And
you can do
outside is
CPU
everything
training.
else. Got it.
Outside is everything else. Yes, exactly. So here currently, or most always, explanation happens outside. Oh, what are my logistic regressions coefficients?
Yeah, we interpret them.
Yeah, we interpret them. Or somebody interprets. Yeah. Here we want the model to interpret them. But back to this. But what was that?
I think it was called Platonic reasoning hypothesis.
Representation.
Yeah.
Okay, I guess.
Yes.
So the conference, I clear, International Conference of Learning Representations. When deep learning wasn't yet mainstream, there was an effort by Joshua Bengio mostly, who wrote a lot of papers of trying to make it mainstream or at least noticed for years. And Andy Kuhn as well was talking about it. One of the explanation was, in order to build good classifiers, we need good features. What does those features? Features are good representations of the problem. Pre-deep learning, this new era, but I mean, anyways, historically, don't start your clock. Everything goes back 4,000 years BC, but everything is connected. But before deep learning, it was you sit down and say, oh, I know this thing is important for this particular octopus. I will measure it, and then it will tell me the healthy status of this octopus. You created features, and then you run SVM, blah blah blah, classifiers. That way, for this crowd, FNC matrices were created. Somebody stumbled upon them, like, hey, look, they are highly predictive features, and they are. Pavel shows FNC matrices, logistic regression, beats or kind of on par with all deep learning methods, working from raw data, from anything, right? Because those are good features. Lee Kuhn and Joshua Bengio and other people were talking about, like Aaron Kurbel and others, that deep learning can learn those features automatically, can find those representations, right? Representation space. That's a clear International Conference of Learning Representations. You start from raw data, you have a task of something, any task. You train your model, and inside of this green box, the model forms representations for itself that help it to make better predictions. Then somebody noticed that if we're, and this comes from World2Vec, everyone who's familiar, who's not familiar, sorry, World2Vec creates a mapping in a high-dimensional space in Hilbert space sense, like a linear space. Semantically meaningful words are closer together. Semantically dissimilar words are farther together, and you get this representation. Now, representation is a word like intelligence, means nothing or everything. But one way of thinking of representation is that vector, the dot in that space. Another one is, well, this whole space is a representation.
Sparsity.
But it's like just dimensionality reduction, right? But
No,
smartly done with.
It's not dimensionality reduction. It's, well, I mean, in a sense, right? You're finding a subspace. It's not just finding a subspace. You are finding a projection of you looking at the laptop, and this laptop is placed in this neuron of my brain and sits there. And this neuron of my brain has nothing to do with that laptop, is just a label.
Mhm.
But near that label, the next neuron is encoding a workstation. And it's just a neuron, it's a label, but they're nearby together. For this, it's not just a label, it's a vector. It's not a neuron, it's kind of a vector. So to construct this vector is not just find a space, but that too. You're not only finding a vector and assigning to everything that you're seeing, but you're also finding a space such that those vectors assigned. So it's simultaneous process. You can't find a space and you can find vectors. You're simultaneously looking for vectors and spaces such that semantically similar vectors are together, and they don't fold on itself. They don't like violate semantics by accidentally putting this semantic group, which is far away, but the space folds on itself, and they appear that you try to avoid that. So that's what the model
Is what you just described the training objective, or is that like a result of something like this?
No, that's not the training objective. That's the result of using over-parameterized models, deep learning, for achieving your objective. Logistic regression, SVM, whatever the classifiers we're using in Polycifier, they cannot do that. That's not their objective. They're just trying to find, even SVM, they're just trying to find the decision boundary, right? to already fit that space. And if your feature space is correct, your points are already on some representation, but this representation was created from your brain, from like your knowledge background as an expert. Here, we're hoping that we will train a model, and it's already happening. This is not forward-looking. This is how deep learning models work.
But you have to have a bottleneck for something like this, right? Or not necessarily?
You have gazillion theories of how they work, but it doesn't matter for this conversation. Somehow they work, right? So somehow they work, and this is what they create in their space. In their weights, inside of their weights, because each layer creates a vector. Okay. Each classifier, each deep learning classifier is nothing but a learnable kernel and a logistic regression on the output. So logistic regression gets those vectors from the last layer. A vector is produced, activations of each input, for each input, right? So you give an input, whatever it is, sound, blah, blah, blah. Layer, activations, boom, you got a vector. Now you apply softmax, that's your logistic regression. Now you're not exactly softmax, but the last layer, linear transformation and softmax. That's logistic regression. So you have a learnable kernel or mapping into a feature space. Learnable, it learns the representation space. Somebody noticed that for large language models, this representation space is kind of similar. That's the Platonic representation hypothesis. But again, the representations are very different. Those vectors are dissimilar. They're nothing like that. But, and that's why I don't like the paper is overselling. But semantically similar vectors are closer together in all of the models in sort of a similar way. But of course, they're trained on the same data. That's how we communicate, because we all here trained on the same data or very similar data. And that's why we can communicate, because semantically similar objects in our heads are similar. And when I'm telling you something, your association chain is similar to what I think. Well, I'm very bad with theory of mind, but it's very good with theory of mind. Like, what will you think when I tell you those specific words, right? But if you came from another planet, no chance.
You wouldn't
Like,
know how.
Yeah, your
what is
data,
this cow? This thing.
yeah. Your data was super different. So, but this is before this. So this dark blue box there, variable discovery, structure discovery.
Yeah, that's not necessarily relevant to world models in general.
It is relevant. It is
Applications,
relevant.
right? Like it's
World models is kind of a next step, because in our head, we're not, well, in our visual cortex, maybe that's all that is happening. It's just feed forward. All of our models are feed forward. Well, our models, the green models. In our brain, we can live in those models, right? We can close our eyes and model situations and then decide, like, do planning and stuff like that. This is kind of a world model. That's what we're trying to do here, ultimately. But we cannot get there immediately. We need to get there step by step. And that's why you need to sell something right now. And you call it world model, but it's just another what? I don't know what this paper is about.
I have a question.
Yeah.
Could you go back to the
Mhm.
slide? Yeah, the tunneling forecasting, it's like we are trying to implicitly learn explanations in our weight space. So what in discovery that I'm trying to understand what's the modality of that explanation. Is the math equation or it's what that explanation means? We are trying to do that the exact thing using our weights, right? In
Activations. Yeah, weights are the parameters of our
so
function.
what's the difference between the first one and the second one?
Well, because the first one is explanation is in your head.
Yeah.
And you think about, okay, what went wrong? What needs to be done? Oh, I need to add more layers. And then this is your explanation of situation that is happening. And we want the model to, like, oh, I'm looking at the mouse in this room, but it's dark, so it's not actually a mouse, or maybe it's a mouse. Maybe I should turn the light on. That all happens inside of the model, and then the model makes a prediction. Go turn the lights on, and we'll see what that is, right? That like this process of explanation is not external anymore; it's internal to the model. That's a dream. That's the kind of the goal. That's like your quad check.
One more question, not to derail us.
Very
but
cyber.
is
This meeting is about derailing.
Okay, sorry. It's like I just this is piquing my curiosity. Has there been any papers to explore like this for diagnosis at all? I'm kind of curious about that.
Pavel just
World models, you mean?
Yeah.
published that one
Did that-
similar.
So I was like, this would be
Well, in a
perfect
way.
for the medical doctors.
In a way.
Yeah, sorry.
I guess if I try to summarize what Sergey said about the difference between explanations and models that use them, it's like you can make a model that will predict the weather tomorrow, and it will predict that based on the observations today. And you can make another model that will also predict the weather tomorrow, but it will do it by like creating a world of weather stuff inside it.
In running a simulation, like
Yeah.
a finite element simulation of where this stuff is going, right? Like for example.
Mm.
That's in the Siberia, they did that in Siberia, they made Tyrol and Claudius made like a little civilization, right? And then it runs.
Which
Yeah.
civilization?
Oh,
Well, I
like,
think the idea is like it's a simulator of something. There is a world under the hood, and if model is working, if world model works correctly, then the world under the hood is representing the real world in some way, and we can poke the model to figure out the world.
Like domain specific AGI. Okay.
Yeah, I guess, can we say that AGI is a world model of intelligence?
do you feel
like-
like LLMs do this or no?
It feels like the more truthful answer is no. They are learning how to make a token prediction, not necessarily understanding what's going on.
I
inside the
disagree.
text.
If it quacks like a duck, works like a duck, come on. I mean, it's just if we don't understand how they do it, it doesn't mean they don't do it.
Yeah. Well, I feel like the training objective itself is not necessarily leading to the creation of world models inside the model.
No, it
But it
does.
looks like.
It
You know
does.
what
It
sounds-
absolutely does. My books are at home. I will show you the examples. No. Like okay. Just give me. Go on. Ask some question. I need 2 minutes.
Why I think that we still see that models sometimes hallucinate, and you can reason that they hallucinate because they have their own ideas.
Humans
and models and
hallucinate
stuff.
so bad. Come on, don't get me started.
Yeah.
Humans don't know what they're talking about.
But at the same time, they just believe in this, and the
Like
world and the LLM just trying to make a prediction.
Okay, try to finish the sentence. Just predict next word. After Ballmer's retirement, the company elevated. So now think about what you need to know in order to finish the sentence. LLMs have that all knowledge, and they can go through the process. And okay, another one. In stacked pennies, the height of Mount Kilimanjaro is. Now I think what kind of knowledge you need to LLMs can do that because they like it's not just next token prediction. Once you do more examples, I will not stop. When the cat knocked over my glass, the keyboard got predict. A shipping container can hold 436 12 packs or 240 24 packs, so it's better to use. Predict just one word.
Yeah.
Okay. After the dog died, Jen hadn't gone outside for days, so her friends decided to predict this one. It's like all of them demonstrate different parts of our world, and you have to have deep knowledge, and you have to be able to model on the fly. Let me try that on Claude. The shipping containers one is really, really fun. I mean, I thought about it. Thinking about comparing packing efficiency. 24 packs if the goal is maximizing products per container, and then it goes on explaining why. Yeah, that's right. You get with 12 packs, you get, although it seems like the smaller part, but you get 5,232 units. With 24, you get 5,760 units, whatever is in packs. Well, anyways. So, but I have a mathematical proof as well. Any function that can, like the universal function approximation, right? If we assume as computer scientists that the world is computation and there is no spooky stuff is happening, it's just computation, then any function that you can represent as a feed-forward function, you can also represent as a recurrent function and vice versa. So if you have a process that is compact and limited by our brain, for example, and churning there, you can represent that process as one single huge function. That's why we're running out of nuclear power, which we don't have, and oil and everything to power those machines, because I mean it's too big. But it doesn't mean it cannot be represented as a function. Even the function is just a mapping of input to output.
In the Siberia, one of the assignments was building an electronic.
Oh, Siberia. Okay, you're talking about
poetry
Lem.
machine. Yeah, Lem, Stanislav Lem. And when they had to build the poetry machine, first they built this like robot, and then they were like, well, we have to put all of history because it needs to know human history.
Yeah.
And they're like,
Yeah.
we need to
Have
put
you read
in
this?
like emotions,
No, I-
concepts like tragedy, and like only then can it write good poetry. But like
No, but you should read the story.
Yeah,
I mean, it's kind of archaic, and I've tried on Eloy, and he didn't get it. But there are two stories in them, 1950s, that completely describe everything that is happening right now with LLMs. Just
Yeah, it's
another
like
one
it
is
works.
Terminus.
It's exactly.
Yeah, it's an LLM.
Yeah.
Another one is Terminus. It's also LLM.
What is
It's
this
like
called? So I can
different
Google
context.
there. Siberia, you said?
Oh, no,
Siberia.
Siberia. It's like cyber, not like Siberia. And
Siberia.
that's what I didn't get. So
Oh, yeah, like Siberia. Yeah.
yeah.
Siberia, yeah.
It's
yeah.
not
Yeah, that's what I-
Siberia. Like I heard Siberia, and I was like,
Yeah.
what did they do in Siberia?
I know.
Like a modeling, like in the Bronze Age, they were in Siberia. They were- Oh yeah. If you put that's described in three-body problem. If you put enough people in Gulag and make them represent transistors and stuff, you can have a machine that does the computation. Sorry, just getting carried away. But
We do it through interpretive
world models.
dancing.
Yeah, world models.
Yeah, one last thing about this idea that LLMs are world models. I'm not sure if I still agree.
Nobody says that LLMs are world models, but they have to have world models. We just don't know how
Well,
it's encoded there.
Yeah. My idea is they may have a world model under the hood, but it's like since they're learning from a lot of data, some sort of world model gets imprinted into the weights. And so it can predict something sensible using only token prediction. But in general, it can fail, and it's not a world model.
What do you mean in general it can fail? In general, nothing works.
I think that we can describe a world model using some kind of laws. Like if it's a world model of solar planetary movement or this kind of thing, you only need Newtonian laws for that. And you can make a model based on it.
You're talking about simulator. So you're in that camp. So we'll discuss you on next Friday. So one camp is like, it's a physical simulator, right? What is a world model? So just you actually simulate, you run the full simulation. And I doubt any one of us does that ever in their head when planning and stuff. So that's one variant of world model. Another one that's common now, more common than physical simulations. Nobody thinking about physical simulations when they say world model now. They think about predictive model. You're just predicting inside of the model before making a prediction, or like, okay, other factors, like, okay, what will this be, or what will that be for this input? Like, so it's a predictive model, more for control, like predict what this, how slippery will the road be 3 meters ahead, whatever, when you're moving with this speed. It's kind of a simulation, but it's just more prediction, heuristic based. Like, you're not running any physical based simulation, just predicting. And yet another one is a causal model, which I think all of the world models should be. When you have a causal model inside of your head, you can do counterfactual analysis. Oh, what if I affect this factor? Then what will the outcome be? Okay, well, then maybe I shouldn't do that. Then the outcome got worse in my counterfactual model. So I have a causal model, so I can, reason counterfactual. We do that all the time. Kids do that. When they talk to each other, imagine everything like that.
I hope people would do that more.
Which people?
I don't think people do. Do
No, kids do that all. Like, oh, like everything like this, but I can fly. Like, and then they like go on like, but nothing else is attached. Not like they don't talk about evolution has changed that led to this. No, just everything exactly like that. And common people love it. And what is it, Avengers? How many millions? It's just like love those kind of fairy tales of the childhood, right? Everything like our world, but some people can do stuff that is possible right now, right? And ever. And so that's counterfactual. And then we can model it, and then we can watch Avengers and say, oh, such a nonsense. Like, scratch that.
That makes sense.
Well, maybe some people don't think it's nonsense. Sorry.
Or like fables, people have always generationally made fables. Like for instance, a fisherman in the Arctic Bowl will be like, oh, there is no fish today because, so some like other explanation through folklore. Like folklore has shaped the way that people perceive things more than I think we can even help. The Roman beliefs are still like in our brains to some extent.
Oh, well, but that's back to LLM, because LLM is our collective subconsciousness, because our intelligence, everything I say is my personal opinion. A disclaimer for the record, which I hold, which is my strong personal opinion, weakly held, right? If you can prove me wrong, I can reconcile. But our language is our intelligence. It's not like humans generally are not too intelligent by each other, but the language keeps us together, and this construct, the language contains all of the knowledge of civilization of the humankind. And so we managed to encode the language in a machine. Well, that's the intelligence of our civilization, at least the stories that we know. It's completely dumb, but we knew that the human civilization is also dumb. We vote for politicians for no good reason. We make people heroes, in best scientists for no good reason. We believe in some paper said this is true. Nobody ever checked for no good reasons. And then finally somebody checks and like, oh, the king is naked. But that happens. Yeah. So same thing. So
the South Park did a bit about that, where the aliens come down to Earth and they see what's on our television, and it's like, oh, they worship Kim Kardashian. We're not talking to those people. We want nothing to do with these things.
Yeah. Well, thankfully, with the right prompt, you can probe the right parts of our civilization. You can avoid. So if you're talking to an LLM, talk to an LLM like with the colleague that you want to talk when this task needs to be done.
I never thought of fantasy as a counterfactual argument, but I guess it could be, couldn't it? That's interesting. Sorry, I'm amazed by that. Sorry, that was a comment. Sorry.
It is the way to model the world, but it's mythological. It's our children's way. Like, more mature people do it also. It's all counterfactual thinking.
I never thought of the two the same, so my mind is blown. But awesome.
And Pavel achieves made an achievement. Jordan's mind is blown.
Yeah. I'm like, yeah, you're right.
We have something like 10 minutes, and I have a couple of slides that talk more about world models, and some kind of philosophical ideas that can be used to improve the idea of world models. So the paper I was reading introduces mechanistic world models, and it's kind of a development of the world model idea. A little bit elaborate for me, but I think
The key word, right, is sort of for two of you. You were going to give us a talk about the dynamic, sorry for interruption, and you're working on we're working here. We don't want mechanistic yet, or we're not there yet. We want, but we want dynamics.
Yeah.
On dynamics.
so. The idea that I'm making to develop world models is think about knowledge discovery in general. What are the common things that are specific to the new insights, new knowledge that you can uncover from data? And it sounds a little vague, but the ideas you can attribute to discovery, to insights, two ideas I talk about. One of them is parsimony, and another one is compositionality. So what these are? Parsimony is your ability to develop some kind of law, insight, knowledge using least building blocks, the least amount of building blocks that you can. It's like, imagine that you need to build a model of the solar system and how the planets are moving. You can use the laws that describe the Newtonian mechanics, and it should be enough. And in addition to these laws, you can invent some
But it's not enough, we know.
Say again?
It's not enough, we know. Mercury and
Well,
other.
almost enough.
Oh,
yeah.
yeah.
We're talking about
just a little
models.
cloud on the horizon.
But in addition to Newtonian laws, you can introduce some kind of magic, like green goblins, that also have something to do with your world model. But
And
the
call
principle-
it special theory of relativity.
But so the idea of
Shots fired.
parsimony is to use less of these building blocks, like use Newtonian laws, but not green goblins to explain the solar. Yeah. And another idea is compositionality. It's also a thing about knowledge discovery, insight discovery. It says that it's basically about the incremental nature of discovery. You can make a new thing, discover a new thing, using already known laws, like you can compose a new law by putting together existing laws. And so these two principles are things that we can try to make into a training objective and embed into the model training and make the world model that uses this objective kind of more mechanistic in the definition of this paper. They introduce a definition, a mathematical definition of the world model. A typical world model like vanilla style consists of variables and mechanisms. It's like the inputs, the activations, and the functions that do something on top of them. Mechanistic world model introduces types and structures, and this is done in order to introduce this training objective. The parsimony objective is trying to minimize the mechanisms, the variables, and the amount of types used in the model. And compositionality objective is reducing the amount of structures, like laws, ideas used inside the model. So that's one
No,
thing
this is
I
actually
feel
a fantastic approach and idea. Like I think, like I don't know if it's if they're talking about the way, if the way it should be done that they are talking about is correct. I don't know, but this is what should be done. I think is I fully share the.
You mean in the terms of developing
In-
world models?
In
do
terms of
something?
mechanisms and compositionality and like it's actually a causal model then once you like think about it that way. But
Yeah.
but maybe there are multiple paths to get there instead of what they suggest. Yeah, we still have 2 minutes.
this is the idea I find most useful for me, I guess. It's like, if we are thinking about making a causal model for this new project, then we probably should think about what kind of objective we will be using for training our model in order to make sure that it's causal in some sense. Well, and I feel like this all of the slides are prepared. There are a few things I also discuss that are related to world models and knowledge discovery. It's like,
So this is more of a kind of high level philosophy
Yeah,
thing, like,
yeah.
oh, we should do something like that. We don't know what we should do, but it at least should kind of be observing some of those properties.
yeah,
Like
I feel
mechanism,
like the general idea of the paper itself is to introduce an extension to world models that will be useful for scientific discovery.
but we haven't defined world models yet. Like we spent a lot of time.
Yeah,
Discussing
world
this.
models,
So
in
yeah.
their idea, I feel like it's a model that is using latent representations to predict and those latent representations describe the state of your environment. It's
But
like there is a world, it is described by some variables, and those variables go into the latent space.
Is the world, you define the world or the data defines your world?
I feel like we assume that there is a world and reduced by it reflects something about it. Like if you're taking pictures of the solar system and you're seeing planets flying around like in circles.
I'll send it to.
Yeah.
You chose a very good background for you for what you're reading.
Oh,
We're recording.
oh.
Oh, because
Look at the building. Yeah, look at the building.
Is the sky or?
No, the building has kind of matching colors. I'm sorry, it's completely really. Look at it. It's like
Is there any weighting? Maybe I
Is
missed
there
this.
any
Is there any weighting on mixture of experts? Because I would think it would it'd be a black box problem to see which expert it's listening to more, right? Or maybe I'm just off. I'm trying to wrap my head around this. This is kind of interesting. Because it's information organization. But when you if it's circular, then how do you know it's not learning more from one expert than the other? Is there any way to do that? That's what I think I'm thinking about understanding.
I'm not sure if experts are circular in any way. It's the reason why they mention this mixture of experts in the paper is because mixture of experts is using a philosophy that's kind of useful for world models. It's a modularity idea. The idea that there are some networks that are doing some kind of job better than the others. And so we can use them to make better predictions. In world models, those submodules are some things that are describing different mechanisms. So they are more stratified in the functional sense compared to mixture of experts. Well, it's also because the end goal is different. World model is trying to make
Yeah, that's right. Sorry.
model of the world.
It's trying to explain, I guess.
yeah, it's not the experts that you're thinking about. It's just their mixture of experts as a model,
It's
like another model.
It's a misnomer, sorry.
Yeah, MOE.
What was the idea?
Pardon?
What
He was
the
thinking it's learning from experts.
Yeah,
Oh.
Like and then there's
I
bias.
was confused by the
It's
word
like-
of expert. That's why I was sitting there thinking, wait, it's in that. Yeah, misnomer, sorry.
Yeah, most
Yeah,
of
that's
the problems with any field is like I don't understand what they're saying because I'm thinking, seeing the words and I'm thinking that they mean this, but they don't mean.
Somebody had DAG, I think, a couple weeks ago, and in neuroscience, DAG is used for calcium co-modulation inside the nucleus.
Yeah.
So I was really struggling to detach from that for some reason. and
Yeah,
it made me
directed
realize-
acyclic graph.
I don't know whose that was. Oh yeah. Oh yeah, thanks. Sorry, I was really struggling with that because I was sitting there thinking, why do I keep going back to this concept? And I'm like, okay, this class has drilled this in me. Sorry.
Oh, because the language drives us. Yeah. Okay. So they don't give anything practical, right? It's an overview.
Yeah, it's
Sort of
more
like,
of a
oh, we
philosophical
have those
paper.
principles.
Mhm.
It's Chalmers gave a talk, philosopher, gave a talk on opening new rib stock 222, I think, in New Orleans, and he was talking about consciousness, and he's a philosopher of consciousness, and also there is like if we find consciousness, then consciousness should have the following properties. We have no idea what consciousness is, but there's following properties. This is like that. We have no idea what mechanistic or whatever world model is, but if there is one, it should have some following properties like that.
Yeah.
And then I don't know, the word mechanistic and mechanism is overloaded as well. It's like very hard for me. Like the same way, like for you, like what do they mean this? What
Statistical mechanism as opposed to, yeah. sure.
yeah. Like it's very hard. Like what do they mean by mechanism and blah 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 blah. It's like structure, okay, I can assume, but again, I'm probably not thinking what they're thinking.
Yeah, their notation is kind of difficult to get through.
But in a way, like, doesn't assuming that the world is mechanistic kind of introduce its own bias?
Yeah, and like what is mechanistic? It depends on what they mean, right? It's
Mhm.
like, and depends on what you mean.
Yeah, I feel like in their context, in the context of their paper, mechanistic is related to the mechanisms inside the model.
Yeah.
And mechanisms has some kind of learnable transformations, I suppose, that are more
Yeah, exactly. That's the point. It's like what, yeah. Okay, well, we gotta go to the next meeting, and thanks everyone who's joined. Thanks, TJ. I will try to summarize a few papers, whatever I will understand by next Friday, about world models. So we will continue. Pavel started from the end. This is kind of the paper that assuming or trying to rethink the world models, but I will also talk about how we got there, what are the world models, and how people are talking about them right now, at least from my point of view. Thank you.